everyone, and welcome to the Environmental Science and Engineering Podcast channel. Today, we will discuss a very important topic, solid waste and its management. Because everything we generate in daily life, from household trash to waste from industrial activities, can cause serious harm to both human health and the environment if not managed properly. In this episode, we will explore several key dimensions of solid waste management: the factors that influence how much waste is generated, the definition and classification of waste, what different countries around the world are doing in terms of waste management, and which processes are used to dispose of or recover value from waste. We will also look at global practices and targets, including the recent advances made by certain countries, such as the European Union members and Turkey with its ambitious Zero Waste project, highlighting some of their unique approaches and achievements in the field.
That's a very good question. In its simplest definition, solid waste refers to any material that contains too little moisture to be considered liquid and must be disposed of. In other words, we are talking about materials that have reached the end of their use in daily life or production processes, are no longer useful, and can pose problems when released into the environment. Its sources are quite diverse: household garbage, waste from schools, hospitals, industrial facilities, and even agricultural operations.
So it's not just about household garbage, it actually covers a very wide range.
Exactly. Defining and classifying solid waste properly is the first step in managing it, because the collection, recycling, or disposal methods to be applied vary depending on the type of waste. That's why classifying solid waste by its source, composition, and environmental impact is a very critical issue.
When we talk about solid waste management, one of the most fundamental questions is this: how much waste does one person generate per day, and what factors influence this amount? Because this is not only an individual matter, but also one that directly affects economic, social, and environmental policies. The average per capita daily waste generation varies greatly depending on the region, income level, and lifestyle. On a global scale, the picture is even more interesting. So, what factors determine this variability?
That's a very important point. Municipal solid waste generation is a dynamic process, shaped by the interaction of socioeconomic, demographic, environmental, and behavioral factors. Let's go through them one by one. First, socioeconomic and demographic factors. As income levels increase, waste generation also increases. The reason is that higher income individuals consume more packaged, processed, and disposable products. For example, in the United States, per capita daily waste generation is about 2.5 kilograms. High-income countries, while representing only 16% of the world's population, generate 34% of total waste. The United States leads with 951 kilograms of waste per person per year. In Israel, this figure is 650 kilograms, in Canada, 684 kilograms, and in Australia, 543 kilograms. In Turkey, it is around 430 kilograms per capita annually.
So, income level determines not only consumption habits, but also directly influences the amount of waste produced.
Exactly. This connects to the second factor: consumption habits and lifestyle. The food culture and consumption patterns of societies determine the composition of waste. In the United States and Europe, where fast food and processed foods dominate, packaging waste is more prominent. In recent years, minimalist lifestyles, the zero waste movement, and the use of reusable products have helped reduce waste at the individual level. However, at the same time, the rise of e-commerce has significantly increased cardboard, plastic, and packaging waste.
The third factor is population density, urbanization, and seasonality. As urbanization increases, so does per capita waste generation, since consumption in cities is higher than in rural areas. In tourist regions, seasonal fluctuations play a major role. Climate also matters. In hot regions, food spoils faster, leading to higher organic waste, while in colder regions, packaging waste and fuel-related waste become more prominent. The fourth factor is waste management systems, education, and policies. In countries with strong recycling infrastructure, per capita waste generation is lower. For example, in Germany, where recycling rates are high, daily per capita waste remains around 1.1 kilograms. In Japan, thanks to strong public environmental awareness, it is only 1 kilogram. In Turkey, however, recycling rates are still relatively low, so a large portion of waste is sent directly to landfills. Here, the role of policy must also be emphasized. In the European Union, source separation of waste is legally mandatory. In Turkey, the recently implemented zero waste regulation now requires public institutions and private enterprises to separate waste at its source.
So, in summary, per capita waste generation is shaped by a wide range of factors, from income levels to food culture to urbanization and recycling infrastructure.
Exactly. To reduce waste generation, technical solutions alone are not enough. Public awareness, legal regulations, and sustainable consumption habits are equally important. So far, we have discussed the factors that influence per capita waste generation. But it's important to understand not only the individual or local dimensions of this issue, but also the global picture, because the amount of waste we generate today doesn't just affect our own cities, it impacts the entire planet. How much waste is currently being produced worldwide? Where's this number heading in the future? And which regions stand out?
According to recent data, the world generates about 2.01 to 2.1 billion tons of municipal waste every year. That translates to roughly 0.74 kilograms per person per day on average. But this average can be misleading because per capita waste generation varies dramatically across countries. In some places, it is as low as 0.11 kilograms per day, while in some developed nations, it can reach up to 4.5 kilograms per day.
So there's a huge gap between countries.
Absolutely. For example, the United States and Israel are among the countries with the highest waste per capita waste generation. In the U.S., annual per capita waste production is 951 kilograms, while in Israel it is about 650 kilograms. Turkey, on the other hand, sits in the middle range with around 430 kilograms per person annually. But the most critical point is about future projections. Current estimates suggest that by 2050, global waste generation will reach 3.4 billion tons. This increase is not only driven by population growth, but also by urbanization and changing consumption habits.
So which regions are expected to experience the fastest growth?
The sharpest increases are projected for sub-Saharan Africa, South Asia, and the Middle East, where populations are growing rapidly and urbanization is still accelerating. At the same time, the economic growth and rapid urbanization of China and India will play a decisive role in global waste volumes.
So it's no longer just about the consumption patterns of developed countries. Developing nations are set to change the game as well.
Exactly. While high-income countries still produce more waste per capita, their share of the world's population is relatively small. In contrast, as massive populations in countries like China and India adopt more consumption-driven lifestyles, the total volume of waste will skyrocket. That's why waste management in the future won't just be a local issue, it will be a global priority.
And what does this picture tell us?
It tells us that waste management cannot be approached narrowly as simply collecting or dumping garbage. Effective recycling policies, sustainable consumption habits, and raising public awareness are essential on a global scale. Otherwise, the projected 3.4 billion tons of waste by 2050 will place enormous burdens not only on the environment, but also on economic and social systems.
So, in summary, waste generation is growing faster than population growth, and this increase will be especially steep in developing regions. That means waste management is no longer just a concern for individual cities or countries, it's becoming a shared global responsibility.
Exactly. If we want to secure a sustainable world for future generations, we need to start addressing the waste crisis with a global perspective today.
So far, we've discussed the factors influencing solid waste generation and the global trends in waste production. But before we can properly manage waste, we first need to define it correctly. Solid waste is not always of the same type. Some are relatively harmless to the environment, while others pose serious health risks. So let's start with a basic question. How is solid waste classified?
That's a very important point. Classifying solid waste is critical because it determines how each type should be managed. Broadly, we can divide solid waste into three main categories: non-hazardous waste, hazardous waste, and medical waste.
Let's start with the non-hazardous category first.
Of course, non-hazardous waste refers to a broad group of wastes that do not possess dangerous characteristics. The most common example is municipal solid waste, which comes from households, workplaces, schools, and public institutions. This includes everyday household refuse, food scraps, paper, plastics, glass, and metals. However, note that by legal definition, hazardous, mining, and agricultural wastes are excluded from this group. Another subcategory is inert waste. These are chemically stable materials that do not break down easily in the environment. For example, construction and demolition debris, such as soil, concrete, bricks, and glass.
So these are mostly construction materials and everyday household trash. But how do we define hazardous waste?
Hazardous waste includes materials that can pose a serious threat to human health or the environment. They can be ignitable, corrosive, reactive, or toxic. Examples include certain chemicals, used motor oil, and ashes from some incineration processes. In particular, wastes containing heavy metals require special management because they can contaminate soil and water.
And I assume one of the most sensitive categories is medical waste.
Exactly. Medical waste comes from healthcare facilities such as hospitals, clinics, and laboratories, and it poses a direct infection risk. We typically divide this category into several subgroups: pathological waste, tissues, organs, and blood; sharps, needles, scalpels, and razors. If disposed of improperly, these can cause serious injuries and transmit diseases like HIV and hepatitis. Pharmaceutical waste, expired or unused medicines and vaccines. Mismanagement of this type of waste poses significant public health risks. That's why modern treatment methods such as autoclaving or microwave technologies are widely used to render medical waste non-infectious, after which it can be handled like standard municipal solid waste.
So, in summary, classifying waste directly determines how it should be managed. Non-hazardous waste can be handled with simpler methods, while hazardous and medical waste require special, secure systems.
That's exactly right. Misclassification or improper handling can lead to severe consequences for both the environment and human health. That's why separating and managing each type of solid waste correctly is one of the most critical steps in waste management.
So far in solid waste management, we've talked about individual and local scale factors. But this problem is not just local. It's a growing crisis on a global level. Worldwide, the amount of waste is increasing every year, and the environmental and economic impacts are becoming more serious. Can you give us a picture of what's happening on a global scale?
The picture is truly striking. Today, more than 2 billion tons of municipal waste are generated globally. If current trends continue, this amount is expected to reach 3.4 billion tons by 2050. That means waste is growing faster than the population itself. The main drivers of this increase are population growth, rapid urbanization, industrialization, and a consumption-oriented economic system. The economic burden is also immense. In 2020, the global cost of waste management was estimated at about $252 billion. When environmental pollution and public health impacts are included, the figure rises to $361 billion.
The United Nations Environment Program warns that without urgent and collective action, this annual cost could soar to $640 billion by 2050. So waste management is no longer just an environmental issue, it has become a necessary part of sustainable development.
So it's not just about collecting trash. We're actually facing a massive economic and strategic challenge. But is this picture the same for every country, or are there differences based on income levels?
There are major differences. High-income countries, while representing only a small share of the global population, generate a disproportionate amount of the world's waste. And the composition of their waste is also different. In these countries, a significant portion of waste is dry and recyclable materials, like plastics, paper, metals, and glass. In contrast, in low-income and middle-income countries, there more than 50% of household waste is organic matter, mainly food scraps and green waste. This difference is directly linked to economic development and consumption habits.
So we can say that as income increases, the structure of waste changes too?
Exactly. As income rises, people tend to consume more processed and packaged products. Naturally, this increases the amount of plastic, metal, and paper packaging waste. Especially in large cities where food and goods are transported from distant regions, packaging becomes inevitable. Long supply chains require more packaging to ensure products arrive safely, which means more dry waste. By contrast, in lower income and rural communities, people often consume local products. Since these are sold with little or no packaging, the waste stream is dominated by organic content.
And how does this difference affect waste management strategies?
It has a huge impact. In high-income countries, the higher share of dry fractions creates better conditions for recycling and incineration technologies. That's why recycling rates are higher and energy recovery through incineration is more common in those regions. In lower-income countries, the challenge is different because organic waste dominates. If this waste simply ends up in landfills, methane emissions become a serious problem. That's why the best strategies in these regions are biological methods like composting or anaerobic digestion. These not only manage organic waste effectively, but also reduce environmental impacts.
So in short, there's no one-size-fits-all solution. Each country needs to design strategies based on the specific composition of its waste.
Exactly. There's no universal formula for waste management. An effective system has to be tailored to local economic conditions, consumption patterns, and the unique characteristics of the waste stream.
When we talk about solid waste management, we often mention several methods: landfilling, recycling, incineration, composting. But it raises a key question: which process is truly better? In other words, what is the most appropriate approach to managing waste?
That's really the central question of waste management. The globally accepted framework is called the waste hierarchy or waste pyramid. At the very top, the most preferred option is waste reduction because the cleanest waste is the one that never gets created. Then comes reuse, followed by recycling and composting. After that is energy recovery, which usually means incineration. And finally, at the very bottom, is landfilling, which is the least desirable option from an environmental perspective.
But in practice, some countries rely more on landfilling while others prioritize incineration or composting. What explains this difference?
Great point. The differences usually come down to geography and policy. For example, in countries with large land areas, landfilling is more common. But in places like Japan, where land is limited, landfilling isn't really possible, so the majority of waste there is incinerated. Europe, on the other hand, has seen a huge shift in the past 30 years. Back in 1995, 61% of waste went to landfills. By 2023, that figure had dropped to just 22%. Instead, recycling and incineration have become more prominent.
So what's the advantage of incineration? Why would we choose to burn waste?
Incineration reduces the volume of waste by 80 to 90% and its weight by 75 to 80%. That's a massive advantage because it drastically reduces the need for landfill space. Plus, the heat generated can be used in steam turbines to produce electricity or provide heating, so waste becomes a source of energy. It's also very effective for hazardous or infectious materials like hospital waste, which can be sterilized completely by incineration. And for certain plastics, paper, or industrial residues that are not economically or technically recyclable, incineration provides a viable disposal route.
But as far as I know, incineration also comes with some problems, right?
Yes, definitely. The biggest issue is emissions. During incineration, harmful gases such as carbon dioxide, nitrogen oxides, and dioxins can be released. That's why it's crucial to have advanced flue gas cleaning and filtering systems. Without them, achieving carbon neutrality targets becomes very difficult.
And what about the advantages of landfilling?
Landfilling is the simplest and cheapest method, which is why it's still the most widely used. Another point is that landfills generate landfill gas, which is about 50% methane. This gas can be captured and used for energy production for roughly 20 years after the waste has been buried. However, the need for large land areas and the contribution to greenhouse gas emissions make it unsustainable in the long run.
So, in reality, there isn't a single best method. It depends on the conditions.
Exactly. If a country has strong recycling infrastructure, then recycling should be prioritized. If organic waste makes up a large share, composting or biogas facilities are more effective. Where land is scarce, incineration with energy recovery can be the right choice, and landfilling should always be the last resort. The ideal system is a balanced combination of these methods tailored to local needs and conditions.
So far, we've discussed how waste is generated, the factors that affect its quantity, and global projections. But one of the most critical issues is this: how is all this waste actually managed? Different regions of the world use different approaches: landfilling, incineration, recycling, composting, but not every country follows the same path. Could you give us an overview of the global picture and explain how management strategies differ from one country to another?
Of course, the global picture of solid waste management is fragmented and largely shaped by the economic status of countries. Worldwide, about 37% of waste is disposed in sanitary landfills. Around 31% is still openly dumped in uncontrolled sites. Recycling and composting together account for about 19%, while incineration makes up roughly 11%. The disparities are striking. In low-income countries, over 90% of waste ends up in open dumps. In contrast, high-income countries apply more integrated and controlled methods. About 39% of their waste goes to landfills, 36% to recycling or composting, and 22% to incineration.
So as income levels rise, more environmentally friendly methods are adopted. What about leading country examples?
Japan and South Korea stand out here. Japan generates about 326 kilograms of waste per person annually, but only 3 kilograms of that ends up in landfills. Its strategy relies heavily on incineration. Around 245 kilograms per person per year is burned. South Korea, on the other hand, follows a completely different model. It has the highest recycling rate among all countries at 54%. On average, 236 kilograms per person is recycled, 91 kilograms is incinerated, and only 56 kilograms is sent to landfills.
So Japan is incineration-focused, while South Korea is recycling-focused, yet both are considered successful. What about countries that lag behind?
The US, Canada, and Israel are often cited as less efficient cases. In the US, of 951 kilograms of waste generated per person annually, 447 kilograms go to landfills. In Canada, it's even higher, 486 kilograms out of 684 per person. Israel is particularly concerning. Out of 650 kilograms of waste generated per person, about 524 kilograms, 80% is landfilled. These figures show that reliance on landfills remains very high in these countries.
And what about Turkey's situation?
In Turkey, the average municipal waste generation is about 1.03 kilograms per person per day. As of 2022, the recycling rate is around 30%, which is below the European Union average of 49%. However, Turkey has launched the Zero Waste Project, aiming to increase this rate to 60% by 2035. This requires significant infrastructure investments and public awareness campaigns, and those efforts are ongoing.
So, effective waste management doesn't mean choosing just one method. Success comes from integrating recycling, composting, and incineration in a balanced way, right?
Exactly. The examples of Japan and South Korea make this very clear. While recycling is often seen as the greener option, controlled incineration of non-recyclable waste reduces overall volume, generates energy, and minimizes the need for landfilling. The real key to success is combining these methods into a balanced, integrated system.
Today, we have discussed many aspects of solid waste management. We talked about how much waste people generate and the factors that influence per capita waste generation. We also examined how different countries manage their waste, which processes they use, such as landfilling, incineration, recycling, and composting, and how they control their municipal solid waste systems. We highlighted global practices, country-specific differences, and the overall composition of household waste across different income levels. Beyond that, we introduced the general management principles of solid waste and explained how this issue is addressed on a global scale.
In future episodes, we will take a closer look at specific processes such as sanitary landfills, advanced incineration methods, and innovative recycling and recovery technologies.
At the Environmental Science and Engineering podcast channel, we prepare our content based on scientific and academic sources, as well as official reports. As environmental engineers working in academia, we bring this knowledge into podcast format to share it with you.
Yes, it was a comprehensive discussion today. I hope our listeners gained a clearer understanding of how solid waste is generated, classified, and managed around the world. We will continue exploring these topics in more depth in our upcoming episodes. See you next time.
Thank you very much for listening. Do not forget to like, subscribe, and follow our channel for more episodes.